Hello. In this section, we introduce Ionet's Ray service. Ray is a distributed server programming framework. If you did reinforcement learning before, many should know. This kind of training may require a lot of simulation environment. One environment, one training. It's like playing Go. You run tens of thousands of environments. The most commonly used is the lib of the Ray framework. In the era of the big model, it is like we have 8 cards in one machine. Common frameworks like DeepSpeed and Hugging Face accelerate. Basically enough. But if you have a lot of machines, dozens and hundreds, typical things like continuous pre-training. Of course, pre-training may require more machines. It requires some GPU cluster management. The advantages of Ray in this scene are revealed. It also combines very well with Hugging Face. Framework including Transformer class. Here is the introduction of Ionet's Ray service. This is actually a feature of Ionet. Let's take a look. This is the page of the Ray service. It's basically a cluster. Multiple servers can be deployed. This is the Ionet file. Deployment is also relatively simple. Just choose a few machines. The key is to understand Ray's programming. Your Python code cannot remain unchanged at all. The Python code you wrote before. Some specific rewriting may also need to be changed. One sentence. Ray is a distributed Python programming framework. In fact, it is to modify some Python modifiers. The code can be distributed and run. In addition, some knowledge of Ray himself. You can learn a little bit about it first. Without this knowledge, maybe I don't know how to program. But I'm going to give you some fairly simple examples here. There are also more commonly used, like how to do this fine-tuning of the large model. To really learn in depth, it also depends on Ray itself, because the Ionet basically provides a Ray environment. The way it solves problems is it's mainly distributed. Ray has two main concepts. The first is the mission. The second is the actor. If you have written distributed programming, systems like Hadoop, there are actors like this to claim and execute tasks. Ray itself also has a lot of application ecology, including Ray training, Ray data. Here is the basic framework of Ray, and training modules. You can learn the other modules by yourself. The key is to program Ray yourself. Here is a brief introduction to Ionet Ray cluster deployment. So just to show you, the core is just a few steps. Mainly, just choose a few machines. Let's take a look. First, deploy. Just choose the first one here. That's not much difference. Mainly different parameters and optimizations. This choice is Ionet. Also the default. This step usually selects all. Next step. This is one of its springboard machines, for the machine where the user logs in. There are so many machines. Let's choose 4090. Currently, only this ray is supported. This UE is generally simulated. Do 3D modeling environment. This is the RE app. Just choose the default one. We learn for testing. Just choose 2 GPUs to establish a small cluster. Just take a look below. Choose 1 hour here. The number of GPUs selected. The following is just to confirm. Then just click deploy. Okay, yeah. Then confirm the payment. This is similar to the process of VM and container. Then you may have to wait a few minutes. Okay, look at this deployment. Then take a look at the deployed cluster. And it goes something like this. This is equivalent to having 2 actors. But on a server, take another look at the management system. Its password is here, right? These passwords are all here. This may take a while, because after starting, maybe a few minutes or even 10 minutes, it starts a cluster. Take a look. This password is here. Copy it. So this is what the cluster looks like. Let's take a look. This is one of its panels. Some of its utilization. This is clustering. This is the node. Let's take a look at the GPU situation again. This node can run on both GPUs. Therefore, 2 workers can be set up. This one has no job for now, so this doesn't show. Mainly depends on GPU utilization. See if it works. Then the code. Both will do. I usually use Jupyter more. Same with this one. The password is also this. Display notebook. We choose this. Take another look. And then we ran some examples. We can open it up like this. This looks better. Then take a look at the general content of Ray. Ray programming is not part of our curriculum. Let's get a general understanding first. The first one, the most basic example. Second, because what we care most about is Hugging Face, is a transformer. This is our most used train. Let's take a look. This is the docking of Hugging Face. We also changed the example according to this. Take a look for yourself. So what we do is we use the training module. Here are some basic examples. You can learn. Ionet actually provides a very good environment. If you have to build this re-environment from scratch, still very troublesome. Let's look at our example. So let's start with this. Is the simplest example. Let's take a look. If I run locally, hello world example. Let's take a look. Sleep function. Sleep for a few seconds. Wait a minute. That's a bit long. About 4 seconds. But if you run on this cluster, and look what we did. Run the code. It's sending tasks to the cluster. Basically, it runs successfully in 1 second. Why is that? It's like running for processes. Running at the same time, possibly on different machines. This explains the clustering parallelism of arrays. Here, just added a modifier. Let's take a look. Only this modifier. Everything else is the same. This remote is the call. And get the results. It's just such a simple example. Let's run and try. Experience how it does parallel. Another is the most common. This modifier. Run it remote. Get is to get the result after running it. Synchronization required. Let's take another example. It is still the most commonly used. Take a look at the GPU information. So let's start with this. The function is the same. This is an example of what we often run. But look at this. This is without modifiers. It's like running on the springboard that we landed on. Let's take a look. This is the F4000. That's the server we logged into. Then how to change it? Let's take a look. Just add a modifier here. Use remote when calling. Get the function return with get. This is a very simple example. Let's take a look. Exactly the same. Just put a modifier here. Look how many GPUs there are, right? Of course. This is a reinitialization. We only need to initialize it once. This is a remote call. Get results here. Let's take a look. This display is 4090. This is our cluster of machines. We can also change it here. 2 machines running. Let's take a look. The result is the same. Because we're both actors on the same machine. Running in a cluster. And that's how you see it. The difference between local running and cluster running. Let's look at a more complicated example. Yes, it's our most common. Training of large models, including the transformer class model, similar to Llama. Perform model fine-tuning. It is also one of the most common tasks. This one's not that familiar. You can take a look at Hugging Face's course. So we're going to fine-tune a model here. Here's an example of a comment. And then we use categorization for fine-tuning. The code is all similar, whether it's classification fine-tuning. Still do SVT. But this is it. You can run a VM to run. I'm not going to run it for you. Refer to the previous VM course. Just run by yourself. And then, let's take a look at the code of the cluster. This requires one of its own S3 keys. You need to apply for Amazon's cloud platform yourself. Take a look at what code has been changed. This is initial. It's just the operating environment. If you run 4090, need such a setting. This game card, not a professional card. This needs your attention. You also need to open an Amazon S3. Because we are distributed training, the final model requires a publicly readable disk. This is also an example of Ray. It's actually in here, using the Ray training framework. This is a local transformer. This is what Ray ran. Yeah, we just changed it. Mainly using the framework of his training. Then we can run. Please replace these two keys with your own. This area can be set by yourself. Everything else is written as follows. Okay, so it starts running. Let's take a look. I have two GPUs. Both of these are used. Uses a CPU. Everyone pay attention to the settings. Two GPUs are set to. If you only write one, use two. It can only use the CPU. We started training. We can take a look at the Ray management page. Take a look here. The model is already being trained after it is loaded. Let's take a look. That's 6 gigabytes of memory. GPU power consumption. It's 80%. Take a look. It should take 5 minutes to complete. After this run, it looks like this. You can test it with one GPU and two GPUs. Specific completion time. Generally speaking, it takes about 13 minutes per GPU. 2, about 7 minutes. Two GPUs are preferably on one machine. If the GPU is on both machines, the improvement may not be so obvious. This is the time it takes to exchange data between GPUs. If the GPU is on two machines, the exchange speed will be much slower. Moving on to the next example. Storage for some other cloud platforms, compatible with S3. The test here is Alibaba Cloud, right? Of course, you can also test some other cloud platforms. The configuration is basically the same, mainly to write more such a version. You can run for yourself. In addition, the model is downloaded on its own S3. There's something else to be aware of. If you are using H100, don't write this anymore. 4090 must write this. 4090 does not have fast communication between graphics cards like NivLink. That's it for the class.